First, let's talk about binomial coefficients. Which is going to lead us to the binomial theorem here in just a few minutes. Did we do this notation when we did probability a while back? Okay. This is the same as NCK. Does that look more familiar? Like NCR on the calculator? Okay. I'm just reminding you what the formula is. N factorial over K factorial times N minus K factorial. Okay, and what I want you to do, let's look at fifth row of Pascal's triangle. Do you guys have that handy? What were the numbers? What were the coefficients in the fifth row? 1, 4, 6, 4, 1. Okay. And now, what we're going to do is calculate. Yes. A few of these binomial coefficients. 4 choose 0, that's how we say that. 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. And we're just going to use the formula, the definition for NCR or NCK or N choose K. It all means the same thing. Yeah.
Time out, Phil.
What?
Yeah.
This is just the definition for NCK. We're just going to calculate all 5 of these.
But where's that from?
I'm just telling you we're going to do. I'm giving these to you. Yeah. These. Yes. This has nothing to do with anything yet.
Got it.
Okay? I'm just saying, let's review the formula. Here it is. We talked about this a while back. And now I'm saying, let's actually calculate these using the formula that you already know to see what we get. Okay? 4 choose 0. N is 4, so we do 4 factorial. And then K factorial would be 0 factorial. N minus K is just 4 factorial. What do we get? Good. Because 4 factorial cancel, and 0 factorial is 1. Okay? The next one is 4 factorial over what? 1 factorial and 3 factorial. This may not be as easy to see, so let's write it out. 4 factorial means 1 times 2 times 3 times 4. 1 factorial is just 1. 3 factorial is 1 times 2 times 3. Yeah, 4. Let's look at 4 choose 2. 4 factorial over what? 2 factorial and 2 factorial again. We're just following the pattern here. K is 2 factorial, and then N minus K. 4 minus 2 is 2 again. Yes?
Why did both ones cancel out?
Because it's just a 1. Because anything divided by 1 or multiplied by 1 is still... Okay. So now we get 1, 2, 3, 4 over 1, 2, and 1, 2. Which you could either figure it out all at once, or if you see that 1 and 2 cancel, we have 12 over 2, which is 6. Do we see anything yet? Maybe. The next one should be 4. And the last one should be 1. Let's confirm. 4 factorial over, oh, yeah, that's right. 4 factorial over what's k? 3. N minus k would be 1. Well, that's exactly the same calculation as this 4 choose 1. It's just the numbers are flipped on the bottom, right? That's not going to change anything. So can we agree the answer is 4?
Yep.
Okay. 4 choose 4 is 4 factorial. K is 4, so 4 factorial. And now n minus k is 0, which is identical to the first one. It's just, again, the denominator portion is flipped, but that doesn't change anything. Answer is 1. Okay, so this may have, well, originally it was, let's just practice these calculations, but the point is, these coefficients relate to the numbers that you get in Pascal's triangle. So this is actually a pretty useful thing because occasionally you might want to expand something larger. You don't have to draw out the triangle every time to figure out the coefficients. That's one advantage. Another advantage is if you're interested in just one of the terms, you don't have to do the entire expansion. You can just do a little shortcut, which we'll talk about in a minute.
How do you know what row to use or what number?
Well, we talked about that yesterday, right? If it's to a power of 5, let's say, you go to the 6th row. You always go one row more than the power. This was just an example. If we were in the 5th row, then this would have been something to what power? Exactly.
6 would be 5.
Yes. Okay. All right. So, let's write down the binomial theorem. What's up?
What?
The binomial theorem looks like this. If I have a binomial to the nth power, we've already talked about how you could use Pascal's triangle to get those numbers that you stick in front of all the terms, right? But now that we kind of see a pattern here, in this situation here, what was the exponent again? It was 4, right? And we just went up 4 choose 0, 4 choose 1, 4 choose 2, and we worked all the way up till we got to 4 choose 4, right? Well, if the exponent is n, what do you suppose we're going to start with? Instead of 4, it'll start with n. Does everybody see that? And it'll be n choose 0, n choose 1, n choose 2, and you work all your way to n choose what? N choose n. Okay? So let's write it out. First term is going to be n choose 0. And do you remember the pattern with exponents? The first variable
Goes up.
starts at the exponent. So if this was to the 4, it's to the 4, right? And then you work your way down so that the next term would have 1 less, the next one would have 1 less, and so on and so forth. How many b's do I have, though? None.
Is it supposed to be written higher than A?
What do you mean higher?
Is the B supposed to be written higher than A?
Sorry.
No, like, I didn't know if
They're
it was
multiplied
like supposed to be level.
Same level. Okay. Plus, what happened to the exponent of a? It goes down every term, right? So, now a is to what power?
-1.
Very good.
That's sad.
And then the exponents for b go up 1 each term, right? So how many b's? b to the first. And now the binomial they're really easy, guys. We just go in order. N choose 0. What's the next one? N choose 1. You guys see how this works? Plus, let's do one more. What's the next binomial coefficient? N choose 2. Good. A to the n minus 2 b to the 2, and we keep going until,
Wait, why did you do n minus 2?
because the exponent for a keeps,
Continuing.
yes, exactly. All right, plus, I'm going to do my last term first before I go before that, because that's easy. The very last term is going to have n, choose n, right? Nathan, okay.
Thank you.
Yep. How many a's for the last term? 0. And how many b's?
B to n.
Very good. Yep.
Wait, okay, so is it because you're subtracting? So you're saying you go until like you have nothing left? So it's like if n is 4, you eventually get it to it's 4 minus 4 in here. And then why does it flip?
What is what flip?
What is the opposite?
I'm not sure what you mean by.
I think I'm good.
Okay.
I'm good at video.
Okay. Let's backtrack, guys. The term before this would be n. Choose what?
Sorry, what was your question?
The term before this would be n choose what?
And choose n minus 1.
Very good.
Wait, what's that word that you say?
Choose.
Choose?
Choose. CHOOSEE.
They're not so easy.
E, sorry.
It was
It's like
just
full of-
Choosy.
At first I thought you said
How many A's? The term before the last
0
one.
plus 1, so 1.
N plus
No, 0 plus 1.
How many B's?
N minus 1.
Very good.
Yes.
So then I switch?
Got it. I got it.
All right. This is the binomial theorem. This might look a little confusing.
Yeah.
Wait, that wasn't the binomial?
No, this is the binomial theorem. Okay. If you need to, I'll do a quick example
With numbers.
with a normal problem where you don't have to do Pascal's triangle. Okay. Let's say we have x plus 3y, and we're doing it to the 4th power. Okay? You have two options here. You could do the triangle,
I'll just keep doing what we're doing.
okay? Or, now that we see these patterns, you start at 4, you do 4, choose 0.
X,
X to what power?
N,
Well, what's n? We don't have n anymore.
X to the 4.
X to the 4. 3y to the 0. And then we just keep the pattern alive. What's the next coefficient? 4, choose 1. The exponent of x goes to 3. The exponent of 3y goes to the first. Notice, 4 and 0 make 4. 3 and 1 make 4. The exponents always add up to the power. Okay?
Wait, time out. Let me just look at this for a second.
You only have to do
Okay, so the last one goes up while the middle one goes down, and the first one is always at 4.
Yes.
Yep, I'm good. How long do you go for?
Until you reach 4, choose 4.
Why 4?
I thought it was,
Oh,
I thought it was,
because it's
I thought it
the
was 3.
fourth power.
Mm-hmm.
Wait, how do you know that it's 4?
It's always this. You always start with this power and then 0 for the first one. So if it were 5, you'd do 5, choose 0. 5, choose 1, and so on and so forth.
It happened for the first binomial theorem. You said look at the 5th row possible Pascal.
That was just to get you guys to see that these binomial coefficients are the same numbers as the rows.
5, you just stopped at 4.
Well, because the fifth row represented what power?
5. So how come this one represent this? Shouldn't this one represent the third then?
No, this is the fifth row again, because the power is 4.
If the power set to 0,
Right.
then it's the first row.
Will we have a choice between using this and Pascal's triangle?
Yes, and sometimes using Pascal's triangle will be ridiculous, and I'll explain in a minute. Shh. Guys, this should not be taking the entire period. Like seriously, this takes 6 minutes every other year.
You want to be here?
Okay, we need to stop talking. Way too much chit chat.
So with the last one, it was
Well, I'm not even there yet because we keep stopping. What's the next term? 4 choose 2. X to the second, good. 3y to the second, plus, good. X to the first, 3y third. Last term,
4 choose 4, x to the 0, plus y.
3y to the
4.
4. Okay? Now, since you have calculators for this unit, okay, here's my advice if you don't want to do, I lost the page. Here's my advice if you don't want to do this formula for all these. Do you remember how to type these in? I mean, we already figured them out earlier, but it's just the NCR button on the calculator. You do 4 NCR 0, 4 NCR 1 if you needed to do it on the calculator. Okay? Math, probability, NCR. I know that was a while ago, but once you do it once, you'll be good for the unit, I think. Okay? Now, we're clearly not done. And in the interest of time, I'm not going to actually finish the problem because you can do that on your own. The important thing is we know how to set this up. Okay? Now, the last part is this. What if you are interested in just one term only? So occasionally you might want to know, hey, what's the third term in the expansion look like? Or what's the coefficient in the 8th term, or something like that. In which case, you don't have to do all this, and you don't have to waste 10 minutes doing a triangle to get down to what number you need. Okay? Here's how we're going to do this, and let's see if we can figure this out. So let's say you want to know about the, let's call it rth term, where r could be any number that's less than or equal to n. For instance, this entire thing is which term? First term. This is the second term, third, fourth. This has 5 terms total. Do you guys see that? Okay. What I want to do is figure out a formula, a shortcut, so that you don't have to like write them all out to just figure out one part of all the expanded terms. Okay? Let's see if we can do this. Obviously, we're going to have n. That doesn't go away. But now look at the relationship here at the bottom. First term, we had a 0 at the bottom. Second term, we had a 1 at the bottom. The 5th term, we had a 4 at the bottom, right? So the rth term, very good. It's just 1 less. And now I want you to look at the exponents. If you had to use these numbers here to create this 4 and this 0, and use these numbers here to create this 3 and this 1, do you guys see what I'm getting at? Mm-hmm. Or use these numbers here to create this 1 and this 3, what would you do? How do you get this first exponent? 4 minus 0 is 4. How do you get this first exponent? 4 minus 1 is 3. Do you guys see that? How do you get the last exponent?
4 times
You make it
It's exactly equal to the bottom number. Do you guys see that? So, using, and this is being general, we're using variables, right? The rth term is going to have an A and a B in it, but I just want to know what exponents they have, right? What's the first one have? N minus r minus 1, whatever that is. And then what's the B exponent?
R minus 1.
Very good. All right. I know this notation is strange, but let me explain again with an example so you guys can see how it's used. Let's say I want to find the coefficient of the term with x to the 4 in x plus y squared to the 30th power. And Aldeb, I think this is going to explain my point that I made to you earlier. If you were to use Pascal's triangle, how many rows would you need? 31. You start with your 1 and your 2 ones, then you start going all the way down until you get to 31 rows, right? It's not hard, it's just tedious. And on top of that, we don't even care about what the entire thing looks like. We just want to know the fourth, where the x to the 4th term is, what number is sitting in front of that term. That's what the coefficient means, right? So let's see if we can figure this out. Here's a couple of questions to get you to think about it. How many terms total will there be? Have we seen the pattern yet? There's always one more than the exponent, right? Remember Pascal's triangle? If the power was 0, how many terms were there? 1. If the power was just 1, there were 2 terms. To the second power, we had 3. You guys see that? So if there's 30 terms total, there will be 31 things that you add up together. Okay? Where is the x to the 4th term? That's the question. So let's work backwards. The 31st term would have how many x's? 0. Do you guys see how I'm thinking about this? The 30th term would have x to the 1st. The 29th term would have x squared. Very good. The 28th term would have x cubed, and then the 27th term has x to the 4. You guys see how I'm getting that?
Is there an easier way to find that?
Not really. But now we're done. All we have to do is plug everything in. Because this is your R in the formula, right? Because we know what term we're looking at now.
your 27 one?
Yes. That's what I meant by rth term. If we're looking at the 27th term, then R is just 27 in the formula. So let's write it out. This is going to be 30. Choose what? And maybe we should make this more clear. R is equal to 27, and now we just use the formula. So it's R 30 choose 27 minus 1, which is 26. And then let's fill in the pattern. X to the, maybe I'll, here, make it, same thing, right? And if you remember the pattern, we just do 30 minus 26 is 4, and then it's the second thing, which is y squared to the 26th power. So if I want to know the coefficient The only reason you write all these out is to make sure there's no other numbers floating around in here. Do you guys understand that? Like if there was a 2x in here, this 2 would get raised to the 4th, and it would multiply the coefficient and make it bigger. Okay? Yes?
So the number on the bottom, like the first parenthesis, 26, is always going to be on the second term? Because that's what you're
Yes.
subtracting?
That's exactly right. Yes?
Okay, what good is the first thing?
What good is the what?
The choose thing. Is that like, do you have to solve that or something?
Yes, we actually are going to type this in the calculator now and figure out the... So, either use the formula or do 30 NCR 26 on the calculator.
Oh, it's that.
27,000.
27,000?
What's the NCR?
405.
Sorry, let me do it.
Okay, so that's the coefficient. This is what they're looking at. You have to think about it a little bit, but using Pascal's triangle with these ridiculously big numbers is going to take a long time. Does that make sense? Let's try one more quick one. Find the 8th term in x minus 2 over y to the 12th. How many rows of Pascal's triangle would you need if you wanted it? 13. So you could do that. But since we're only looking for the 8th term, we can use that shortcut again. Shortcut is 12. Choose what? What's r here? R is 8. What do we put here?
7.
It's always one less. So it's 12, choose 7. And now we just follow the pattern. First thing is x. What exponent do I use? Good. How did you get that again? You just do 12 minus 7. Good. And then the second thing is a negative 2 over y. And that is to the 7th. So instead of doing Pascal's triangle for a while, this is all we need to figure out.
Wait, I have a question.
Yes.
Why was R8 the same?
Why was what?
Why was R8?
Because it told you 8th term.
But didn't you already find what we found?
It's not x2.
I know, I got it.
Sorry, Colleen, go ahead. Before what?
No, I'm good.
Are you sure? What's that? Where'd you get 13 from? And we use 30. So it's always the same the exponent is exactly the number that you put on top. Okay? And again, use the calculator. What's 12 choose 7 going to be? 792. X to the 5th. And now we have to figure this out. Y is obviously going to be to the 7. Negative 2 to the 7, though? What is that? Negative 256? Negative, oh, it was off by it. Well, negative 128. So we're almost done. Now we just clean this up. Take 792, multiply it with this number that's still in here. We get negative something big. Help me out. 300 and... Thank you. X to the 5th. All over y to the 7th. So this is our 8th term. I did another example of each because it felt like you guys probably could benefit from it. So that's it for today. We're done with the section.